Here is the last section of differentiation. Differentiability implies, here is a theorem, an important theorem. Sometimes, so this theorem will be asked, sometimes the chance is less, but a question can be asked for the examination. Differentiability implies continuity. Differentiability implies continuity, but the converse is not true. The converse is not true. What do you mean by that? If a function is differentiable at x is equals to a, then it is continuous at x is equals to a. Okay. But if the function is continuous at x is equals to a, it does not mean that it is differentiable at x is equals to a. Okay. May be differentiable if the function is continuous at x is equals to a. There is no hard and fast rules. It is continuous, sorry, differentiable at x is equals to a. It may be differentiable at x is equals to a, or it may not be differentiable at x is equals to a. But if a function is differentiable at x is equals to a, definitely will be continuous at x is equals to a. Okay, let us prove it. That is, if a function is differentiable at x is equals to a, if a function is continuous at x is equals to a, then it is differentiable at x is equals to a. But if the function is continuous at x is equals to a, but the function is continuous at x is equals to a, does not means that it is differentiable at x is equals to a. May be differentiable at x is equals to a, may not be differentiable at x is equals to a. That is the meaning of that particular statement. Let us prove it. So, no need to write this one. And before that one, before the proof, let us take some basic definition of what it is, derivatives. F dash of a means if f of x is there, f of x is x square plus say, then f dash of x is 2x, then a is the number, the f dash of 3 is say, 3 into 2 is 6, this is f dash of 3, a is the number, a is the value of x, okay, a means a is the value of x, f dash of 3 is 6. We can work out f dash of a directly by the first principle in the first theorem is taken. But the f dash of a formula, limit x tends to a is the first principle formula, by the first principle formula. First principle formula, f dash of a is equals to limit x tends to a, f of x minus f of a upon x minus a, f of x minus f of a upon x minus a. So it is the f dash of a. Left hand derivative, L f dash of a, same formula, L f dash of a, left hand derivative, L f dash of a is equals to limit x tends to left hand means a minus, then continuity you have seen, left hand limit means x tends to a minus means x is less than a minus means x is less than a, f of x minus f of a upon x minus a, or f dash of a is equals to limit x tends to a plus f of x minus f, or right hand derivative, okay, right hand derivative, it is left hand derivative, x tends to a plus means x is greater than a, f of x minus f of a upon x minus a, denominator is same, f of numerator and denominator are same, so here it is x tends to a plus means x is greater, less than a, x is greater. Okay, so limit function is what it is, limit exists. Limit of f of x exists at x is equals to a, left hand limit is equals to right hand limit. No, similarly, f dash of a exists at x is equals to a if left hand derivative is equals to right hand derivative. Okay. If Lf dash of a is equals to Rf dash of a, then limit is said, then the derivative is said to be exist. Then f dash of a is said to be exist. F dash of a, in short, f dash of a is derivative of f of x at x is equals to f dash of a means derivative of f of x at x is equals to a. F dash of a is exist and it is equals to L f dash of a, and f dash of a is equals to either L f dash of a or is equals to R f dash of a, because both are equal. No? If L f dash of a is not equals to R f dash of a, then derivative of the function f of x does not exist at x is equals to a. If these are all the points to be remembered for the theorem, okay, for this particular theorem, okay. I have given the theorem statement, proof is not yet started. These are all the basics. If L f dash of a is not equals to R f dash of a, not equals to R dash of a, then f dash of a does not exist. F dash of a means derivative of f of x at x is equals to a. Then f dash of a does not exist. Does not exist. So those lame reasons, I have left the groups, I have not seen the videos, that will not what it is entertained, because in the beginning only number of times I told, if you are not interested, leave the group now only. Then don't tell I have not watched the video, etc. Okay, so that lame reasons will not serve, will not what it is entertained, and so far who are in the group, so they have to pay the fees. So very strange, my friend, side by side what it is, tuition class is there, no? He has started in online in June only, okay, and 15 days he has started and told the student to what it is, pay the fees. Everybody is paid, everybody paid, and at the same time, so they are telling to, instead of coming to the class and wasting the time 2-3 hours for 1 hour sake, class he is taking, and by bus or from home to classroom to home, 2-3-4 hours, unnecessary wastage of time will be there. Better to continue in the Zoom only. We are not ready to come to the class. Continue the class in Zoom only. They are insisting. They are insisting that fellow continue with the Zoom only. We are not ready to come to the class. But you people are interested to attend the class. It seems to be intentionally different. Not of all. Majority of the students' intention is different one. Seems to be not for learning one. So Zoom is not convenient. I have started the videos. Videos you can revise it any number of times, uploading it to the mobile or computer or TV. Better than the classroom you can features, because you can revise the video again and again. But you people are science nowadays, that is the what it is trained. Science students are not for learning sake. They are majority of the science students are after the enjoyment. But earlierly it was not like that. Science students are hard-working students, and commerce and art students are, these students are mischievous students. That was the, but the thing is reversal. They are working hard sincerely. Now science students are after the enjoyment. Now coming to the proof. These are all the what it is, some theory necessary for the what it is proof of this theorem proof. Consider f of x minus f of x. Consider f of x in the textbook it is given as c. In a plus c1 is the same. Okay, f of x minus f of a. Or let us take, okay, c1. In place of A, let us take C. So the textbook C, then A plus C, x is equals to C. Okay, consider f of x minus f of C. Everywhere I have taken A in place of A, we can even, and in the formula we can take it as C, one and the same. Okay, A is the number, C is the number, x is equals to A, x is equals to C. F of x minus f of C, consider this equation is taken. Dividing numerator and denominator by x minus C. Okay, that's equals to f of x minus f of C upon x minus C into x minus C. What I did, x minus C multiplied and x minus C multiplied. Okay, to have this particular expression, f of x minus f of A upon x minus A plus I have taken C. Okay, the proof. Or even we change the statement. If A function is continuous at x is equals to C, then the differentiable at x is equals to C. Continuous at x is equals to t. Everywhere let us make it as C. Okay. Log then A is a number, C is also a number. Let us make it as C. Okay. Taking limit x tends to C on both sides. Taking everywhere C mark like this. A is the number, x is equals to A or x is equals to C is the number. Taking limit x tends to C on both sides. Limit x tends to C, f of x minus f of C upon x minus C. Sorry, f of x minus f of C is equals to limit is taken to this spot as well as this spot. Limit x tends to C, f of x minus f of C upon x minus C into x minus C. Okay. Now limit of f of x minus f of C, limit f of x minus limit f of C. Limit can be taken to both the parts. Is equals to limit x tends to C, limit f of x plus or minus g of x, limit f of x plus or minus limit g of x. Limit can be taken to each and every terms. Limit f of x as x tends to C minus limit x tends to C f of C is equals to it is limit f of x into g of x is limit f of x into limit g of x for both the parts, both the factors limit is taken. Both the factors limit is taken. Okay, limit f of x into g of x is limit f of x into limit g of x. For each and every terms, each and every factors we can apply the limit. The limit f of x minus f of c divided by x minus c into, for this part also limit is taken. Limit x tends to c x minus c. This simple evaluation, this simple evaluation of the limit. In place of x you take it as c, f of c. X place limit is evaluated by taking x is c. But f of c is a constant. F of x is x square, f of 2. Suppose c is 2. 2 square 4 constant. No, limit of a constant is constant only. Therefore limit of f of c, because f of c is a constant. Is it not? F of x is x square. Then x is 2. F of 2 is 2 square 4. Therefore f of c is a number, a value for x of x. X is equals to c. Okay. Therefore it is limit of constant is constant only. Limit is evaluated. And what is this one? By this formula. That's why I have given the formula. Nothing but f dash of c, no? F dash of c into what is the x minus c. Take x as c. This c minus c. What I got here? Something went wrong. F of x minus f of c. Don't evaluate this limit. Okay. Don't evaluate this limit. You keep it as it is. Limit x tends to c. F of x minus limit x tends to c. F of c. Okay. Don't evaluate that limit. LHS don't evaluate. By this formula, it is dash of c. Now evaluate this limit. I am sorry, LH. You don't evaluate the LHS limit. Okay. Then limit x tends to c. X, wherever x is there, you put at c. C minus c. How to evaluate the limit? The simple technique is take x is equals to c if it won't take indeterminate form. If it takes indeterminate form, then other techniques of evaluation of limit is to be used. But one takes indeterminate form by direct substitution. Just to take x is equals to c. C minus c. Okay. So limit x tends to c. F of x minus limit x tends to c. F of c is equals to f dash of c into 0. C minus c is 0. F dash of c limit, this is the f dash of c by the definition, which here only the definition is there. We actually start from here. These things are supporting things, not necessary for examination. The theorem is asked, only to start from here. Limit of x tends to c, f of x minus limit x tends to c, f of c is equals to 0. That's equals to what? 0. Now take, therefore limit f of x as x tends to c is equals to f of c. What is this? Limit of f of c is f of c only. Okay. Limit of f of c is f of c only. Here this part is evaluated f of c. Okay. Because limit of constant is constant. Because limit of constant is limit of k is equals to k. Where f of c is a constant, no. Therefore limit of constant is constant. This part of limit is evaluated. Limit of f of c is f of c only. This part is not evaluated, kept as it is. Limit of constant is constant, f of c is constant. Therefore limit of f of c is f of c. Now f of c is taken to the right hand side. Can you tell me what is this particular definition? This is the definition of continuity. Now, a function is said to be continuous if the limit of the function is equals to value of the function, that is limit f of x as x tends to c is equals to f of c. Then the function is continuous at x is equals to c. Implies f of x is continuous at x is equals to c. That's the end of the proof. Let us prove the converse of it. Means continuity does not imply differentiality. Continuity, conversely, you have to prove the converse also. This is the direct proof. Now converse proof you have to take. Conversely, continuity does not imply differentiality. Continuity does not imply differentiality. Implies differentiality. Let us give a counter example. I told you a particular theory fails can be proved by taking a counter example. For one particular case, a particular theory fails, then that theory is not a true theory. Generally, true theory is may be true or it may be false. For some cases, it means the theory is false. Okay, the theory is true for some case and false for some case, then it is accepted as a false theory. Okay, that's why. So conversely, continuity does not imply differentiability. So failure case can be proved by one particular case or by taking one particular example. That's called counter example method. Let f of x is equals to mod x. We know that mod x is continuous at origin. The graph of mod x is like this, no break at all at x is equal to 0. Okay, no break. Graph is continuous. Okay, and you have proved in continuity section also. Mod x is continuous at x equals to origin. Left hand limit is equal to right hand limit, or limit f of x as x tends to 0 is equals to f of 0. You have proved. Okay, f of x is mod x. Now let us take. We know that mod x is continuous. We know that mod x is continuous at origin. Is continuous at origin is at x is equal to 0. but is it differentiable? Left hand, let us take the left hand, or it is left hand or f dash of 0. If it is differentiable, then left hand derivative is equals to right hand derivative. What is the or f dash of 0? Here 0 is taken, x is equals to c, c value which is taken, 0 is taken, okay. Origin x is equals to c, c is 0 here, okay. Origin means 0, c means one particular value of x, okay. It is limit x tends to this formula. I had given the left hand derivative formula, 0 minus c is 0 here, okay. C is 0. 0 minus f of x minus f of 0 upon x minus 0, okay. That's equals to, what is the f of x? Mod x. F of x is equals to mod x. Mod x is equals to, you know, the full expansion of mod x. It is plus x, x only, if x is positive, minus x, if x is negative, 0, if x is 0. It is the definition of mod x, no? Full form of mod x. Mod x is x only if x is positive. Mod x is minus x if x is negative. Now x is less than 0 minus means x is less than 0. A minus means less than a. A plus means greater than a. Therefore, what is the f of x? F of x should be taken as minus x. Therefore, limit x tends to 0 minus, it is minus x. What is the f of 0? When x is 0. When x is 0. X is 0. What is the f of 0? F of 0 is 0, no? 0 upon x minus 0, because if x is tends to 0 minus, x tends to 0 minus implies x is 0, x is less than 0, mod of x is minus x, f of x is mod x, that's equals to minus x. X tends to 0 minus implies x is less than 0. For x is less than 0, f of x is mod x. F of x is mod x. Mod x is minus x. Therefore, f of x is taken as minus x. Okay? That's equals to limit x tends to 0 minus x upon x. That's equals to limit x tends to 0 minus 1. Limit of constant is constant. LHL is equals to minus left hand derivative of LHL. Left hand derivative with minus 1 I got. What is R f dash of 0? Same, no? F dash of 0, limit x tends to, here c is 0. C is taken as 0. Okay? For this particular counter example, x is equals to c. C is taken as 0. Okay? Limit x tends to 0 plus f of x minus f of 0 upon x minus 0. C plus 0. Look at the f dash of a and L f dash of a formula. F dash of c or f dash of c, L f dash of c formula was given, and we had what it is formula. C is taken as 0. C is one value of x. It is 0 is taken here. Okay? At 0 I have discussed the continuity. Now x tends to 0 plus means x is greater than 0. X tends to 0 plus implies x is greater than 0. For x is greater than 0, for x is mod x, x is greater than 0. ಇವೆಲ್ಲ ಬರೆಯೋದು ಇವೆಲ್ಲ ರೌಂಡಪ್ ಹಾಕಿರೋದು ಯಾವುದು ಬರಿಬೇಡಿ ಎಕ್ಸಾಮಿನೇಷನ್. f of x is mod x is what? X only, no? Mod x is greater than 0. f of x in ಫಾರ್ಮ್ ಏನಾಗುತ್ತೆ? f of x ಗೆ ಏನು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರುತ್ತೆ? mod x ಏನು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರುತ್ತೆ? x ಆಗುತ್ತೆ. if x is greater than 0. ಒಂದು ವೇಳೆ x ನೆಗೆಟಿವ್ ಇದ್ದರೆ mod x ಏನಾಗುತ್ತೆ? minus x ಆಗುತ್ತೆ. mod x is equals to minus x. therefore f of x ಏನು ತಗೋಬೇಕು ಇಲ್ಲಿ? x. for x is greater than 0. x tends to 0 plus means greater than 0. Greater than 0 ಗೆ f of x ಏನಾಗುತ್ತೆ? f of x is mod x ಏನಾಗುತ್ತೆ? x ಆಗುತ್ತೆ. ಹೌದಾ? therefore limit x tends to 0 plus x minus f of 0 is 0 ಅಲ್ಲ? x is 0. ಹಾಗೆ f of x ಏನಾಗುತ್ತೆ? 0 ಆಗುತ್ತೆ. means f of 0 is 0. x is 0 ತಗೊಳ್ಳಿ. f of 0 ಏನಾಗುತ್ತೆ? 0. x minus 0 upon x minus 0. and the limit x tends to 0 plus x upon x is 1. Limit of 1 is x ಕಟ್ ಆಗೋಯ್ತಾ? 1 ಆಯ್ತಾ? limit of 1 is 1. therefore LHL is minus 1, RHL is plus 1. Therefore, f dash of 0 LHL is not equals to RHL. Therefore, f dash of 0 does not exist. It means function is mod x is continuous at origin, but it is not differentiable. Mod x is continuous at origin and customer sir. Therefore, what it is? L f dash of 0 is not equals to R f dash of 0. Therefore, f dash of 0 does not exist. Even though f of x is continuous at origin, but it is not differentiable at origin. Therefore, f of x is equal to mod x is continuous at origin. Continuous at origin, but it is not differentiable at origin. It is not differentiable at origin. Origin is 0. Origin, that is at x is equal to 0. That is at x is equals to 0. Implies difference continuity does not implies, that is continuity does not implies differentiality. Does not implies differentiality. Okay. Then a failure theory fails can prove by one counter example. Okay. Even I can see the example derivation. So mod x is continuous at origin. This is almost end of differentiation. Tomorrow onwards I will start application of differentiation, provided if you have paid the fees. You pay fees and pay temporarily I am halting. Okay. Temporarily class stop ಮಾಡಬೇಕು ಅಂತ ಡಿಸಿಷನ್ ಬಂದಿದೆ. Okay. But fees ಬಿಡೋದಿಲ್ಲ. ನೀವು ಏನು fees ಬಿಡೋದಿಲ್ಲ ಮನೆ ಬರ್ತದೆ. ಸೀರಿಯಸ್ ಆಯ್ತಾ? ಹೇಳಿದ್ರೆ ಬೇಜಾರಾಗುತ್ತೆ ಆಯ್ತಾ? ಹಾಗಾಗಿ ಈಗ so f of x is mod x. It is continuous at origin. Prove ಮಾಡ್ಕೊಳ್ಳೋದು. Limit of f of x as x tends to 0 is equals to limit of mod x as x tends to 0 mod 0 ಆಯಿತು. ಹೌದಾ? How to prove it function is continuous? Limit of the function is equals to value of the function. f of x ಅಂದ್ರೆ mod x. f of x is mod x. x ಗೆ 0 ಇದೆ. Evaluated by that function mod 0 is 0. F of x is mod x. Therefore, it is the limit of the function over. What is the f of 0? Mod 0. Mod 0 is also 0. Therefore, limit of f of x as x tends to c is equals to f of the x tends to 0 is equals to f of 0. Limit of the function is equals to value of the function. Therefore, f is continuous. F of x is mod x is continuous at origin. At x is equals to 0. Okay, it is the proof of what? Limit of the function is equals to value of the function, then it is continuous. The function is continuous.